Good morning to all. In last class, we learned question number 6, 7, 8, 9 in exercise number 1.3. Chapter is Relations and Functions. From these 4 questions, one 5-mark question 100% guarantee in final examination. And all these 4 questions are related to invertible of a function. We need to show that function is invertible and we need to find its inverse. Related to invertibility and finding inverse of a function, related to this topic, 2 worked examples are there. So in this class, I am going to do those 2 worked examples. You see this example. What is the main information in this question? They given that f is a function from n to y. Okay, f is a function from n to y. We know that n is natural numbers. What about this y? We do not know. Let's see any information is given. They given f from n to y is a function and the function is defined as f of x equal to 4x plus 3. This is important information. They given that f of x equal to 4x plus 3 and here you see they given some information related to this set y. What is y? They mentioned here. In the question only they mentioned what is y. What is y? It is an element and which is a natural number. That means the set y is all natural numbers. What type of natural numbers? Whenever I take x is a natural number and I substitute in this, what values this 4x plus 3 gives? Those values will be there in set y. Do not confuse. Here they mention domain is natural number. X, you take any natural number, you substitute here. Whatever the value you will get, that is a natural number they are saying. It is not going to it's not much important while doing the solution, but you need to know what they given here. Y is a set which contains natural numbers. What natural numbers? Whenever you take x is a natural number and substitute in this, what answer it gives, all those things will be present in this set y. I hope you understand. Okay, what they are asking, see from here to here this information is given information. Now we need to show that this function is invertible. We need to show this function is invertible and we need to find its inverse. Okay, in last class also we discussed when we say function is invertible, when the function is 1 function and onto function, then we say the function is invertible. So my intention is I need to show that given function is 1 function and onto function. First I'll write the given information. This is the given information. What they given, f is from n to y and they given that f of x is 4x plus 3. These 2 things they given in the question. As I need to show that the function is invertible, what I'll do, I'll check 1 function onto function first. 1 function, by this time you got the clarity that how to check 1 function onto function. How to check 1 function? First I'll take f of x1 equal to f of x2 and then if I get x1 equal to x2, then I can say that given function is 1 function. First I take an f of x1 equal to f of x2. What is f of x1? As f of x is 4x plus 3, what is f of x1? F of x1 is 4x1 plus 3. Okay. What is f of x2? F of x2 is 4x2 plus 3. In this, in place of x, you write x2. Okay, now 3 will get cancelled. You will get 4x1 equal to 4x2. You see here this 4 also will get cancelled. You will get x1 equal to x2. I hope you are understanding. What happened in the beginning, I considered f of x1 equal to f of x2. I got x1 equal to x2. When I got this information, I will say that the function is 1 function. In exercise number 1.2 also we proved so many times this, right? So I checked that the function is 1 function. Okay. Now about onto function. Here is the part. Whenever onto function will come, question mark will come to in your face because for problem to problem, verifying onto function will vary, but I chosen the easy method. In what way I can prove this onto function easily, that method I taken in almost all every problem. What I am trying to say, whenever checking onto function comes, there is a chance you will confuse. What is the solution for that? Only the solution is practice. Practice. Whenever onto function is there, you clearly observe. Whenever you are checking given function is onto function or not, you just clearly observe what is happening. Okay, here actual main thing is this. What is the definition of onto function? For every element in codomain set, there exists x in domain set such that f of x equal to y. For every y belongs to y, there exists x belongs to domain set such that f of x equal to y. When you prove these three things, then we can say the function is onto function. That is what we learned from the definition. Okay, this thing I am trying to prove now. See, first what I taken an element y in codomain set. I taken an element y in codomain set. For that, I need to get an element in domain set. This function is from where to where? In the question they given that the function is from n to y. They given like this. So I taken one element here. I need to find one element here, right? So here, what I am trying here, I need x value. I need to say that x is also natural number. For this small trick, you do this in the margin. It's not a part of the solution. To find this x, what you will do? First, you take f of x equal to y. In previous problems also we did like this. What is f of x? 4x plus 3. 4x plus 3 equal to y. From this, you simplify, you will get x. What is x? X is y minus 3 divided by 4. You take this only. Now, what to check? Whenever y you take, whenever y belongs to y, x is a natural number or not. In the question they given that y is a natural number. Here one important point is you may confuse with this y value. Here y is a natural number I am saying, but every natural number we cannot take. See, what is this y? They given in the question. You see the question, what they given, what is y? Y is a natural number, but what type of y it is? Whenever you take x is a natural number and substitute in this expression, what y value gives, that only we can take. For example, in place of x, if I take 1, y value is what? Y value is 7. So here in this set 7 will be there. In this set 1 will be there. In this set 1 will be there. No, because this minimum value is 3. Whenever x is a natural number, this minimum value is 3. You please try to understand. Minimum value is 7 moreover. Whenever you take x is a natural number, this minimum value is 7. So what I am trying to say here, y is a natural number, but not all natural numbers. So whatever natural number you take, x is a natural number or not, you just check. No need to check that also. Generally, this is always holds good. What you will write, for y belongs to y, there exists x belongs to domain. That you need to write. How to take this x? You just take f of x equal to y and write x in terms of y. Okay. Now, we need to check that f of x equal to y or not. Definitely this holds good. Important thing is, we need to prove that f of x equal to y. Okay, f of x. What is x? Look here, what is x? X is y minus 3 divided by 4. Now, f of y minus 3 divided by 4 I need to calculate. I know f of x. What is f of x? F of x is 4x plus 3 they given in the question. Now, in place of x, you just write y minus 3 divided by 4. In this, in place of x, you write y minus 3 divided by 4. What you will get? 4 into y minus 3 divided by 4 plus 3. 4 will get cancelled. Y minus 3 plus 3. Minus 3 plus 3 also will get cancelled. You will get y. I hope you are understanding. So what happened here? I proved that for every y belongs to y, there exists x belongs to n such that f of x equal to y. Same thing I written here. For every y belongs to y, there exists x belongs to n such that f of x equal to y. This tells you that the given function is onto function. Okay. Right. So from 1 and 2, what I can say, what is 1? 1 says that given function is 1 function. 2 says that given function is onto function. From 1 and 2, when the function is 1 and onto, I can say that it is bisect 2. When the function is bisect 2, then only inverse exists. That is what we learned in previous classes also. When the function is 1 and onto, then we say bisect 2. When the function is bisect 2, then inverse exists. When I came to know that function is invertible, then I can use this information. This is from the definition of inverse of a function we will get. Whenever f of x equal to y, then x equal to f inverse of y. Now, they are asking to show that this function is invertible. I shown that this function is invertible. Now they are asking to find its inverse. To find its inverse, what is the procedure we will follow? First, I will take f of x equal to y. F of x is what? 4x plus 3. I will write x in terms of y. See here, as the function is invertible, I got this step now. X is nothing but f inverse of y. What is f inverse of y? F inverse of y is y minus 3 divided by 4. So, in this question, they are asking that show that the function is invertible and find its inverse. So, I shown that this function is invertible and I calculated its inverse. I hope you are understanding this. Now, we will see one more example related to inverse of a function. This problem, last problem, both are similar. You first try to understand what they given. They given that f from n to r is a function and the function is defined as f of x equal to 4x square plus 12x plus 15. This is also one of the important question. Many chances are there this question they can ask for 5 marks in final examination because little difficulty is there in this. Okay, this is the given function and they are saying f is from n to r. Okay, show that f from n to s. You need to observe one point here. This is f from n to r. You observe here. This is m from n to s. Here this is r, this is s. Difference is there. You try to understand. Which function they are asking to show invertible? Which function they are asking? They are asking to show that this function is invertible. We need to show that f from n to s is invertible. What is s they mention? Where s is range of the function. They given s is range of the function. Find the inverse of f. Do not confuse. In the beginning, even though if they give like that, we need to show that this is invertible. We need to show that this is invertible and we need to find inverse of f. Okay. So what I'll do, I'll take f from n to s. You try to understand. I taken from this f from n to s. What is s? S is range of f. How do you know s is range of f? They given in the question. S is range of f. Okay. F is from n to s. And f of x is 4x square plus 12x plus 15. They given like this. In last class also we did a problem like this. You remember one point. Whenever f of x is 4x square plus 12x plus 15. That means whenever f of x is in the form of ax square plus bx plus c. And we need to find this inverse. Then we will go like this. See, last problem also I explained. What I am trying to say here. This 4x square plus 12x plus 15 can be written like this. See, this 4x square is there, na? So you can easily understand 2x whole square is 4x square. First you write 2x. Now 2 into 2x you write. Okay, you keep this in your mind. 2 into what I am saying? 2 into 2x. 2 into 2x into, by writing what number here, you will get 12x. By writing 6, you will get 12x, right? Okay, you observe here. This 2x you can easily understand because 2x whole square is 4x square. As 4x square is there, immediately you will get an idea to write 2x here. Once you write 2x here, you keep this 12x in your mind to write next step. 2 into 2x into, by writing what number here, you will get 12x. By writing what number here, you will get 12x. 2 2s are 4. 4 3s are 12. So I need to write 3 here. So here you write 3 whole square. Now what you will do, you expand 2x plus 3 whole square. You will get a 4x square plus 12x plus 9. But here 4x square plus 12x plus 15 is there. Here I got 9. To get that 15, I'll add 6. I hope you are understanding. So with little bit of practice, you can write this expression like this very easily. With little bit of practice, this expression you can write like this very easily. Okay. Now the given function I written in this form. If you simplify this, again you will get this expression only. Now what is the question? We need to show that the given function is invertible. For that I'll check 1 function as well as onto function. What is 1 function? First you take f of x1 equal to f of x2. What is f of x1 in this expression? In place of x you write x1. Okay. What is f of x2 in this expression? In place of x you write x2. Now you see plus 6 will get cancelled. 2x plus 2x1 plus 3 whole square equal to 2x2 plus 3 whole square. Right? This square when you apply square root, the square will get cancelled. 2x1 plus 3 equal to 2x2 plus 3. From this 3 will get cancelled. You will get 2x1 equal to 2x2. Right? So from this x1 equal to x2. Whenever f of x1 equal to f of x2, then we know that x1 equal to x2. Right? So what we got here, we taken f of x1 equal to f of x2. From that we got that x1 equal to x2. So from that what I can say? I can say that given function is 1 function. Now I'll check with the onto function. Onto function is easier because they given that s is nothing but range of the function. You see here f is from n to s. Na? What is s? S is codomain actually. But in the question only they given codomain is nothing but range of f. What is s? S is codomain. In previous classes also we got a point like this. Whenever we are trying to prove onto function, you identified that codomain is same as range, then directly you can write that function is onto function. So here this function is onto function. I came to know that this function is 1 function and onto function. From 1 and 2 what I can say? I can say that this function is bijective. We know that when the function is bijective function, it is invertible. right? When the function is invertible, then you can write this point f of x equal to y if and only if x equal to f inverse of y. Okay, now last thing, we need to find its inverse. First, I'll take f of x equal to y. Okay, what is f of x? 2x plus 3 whole square plus 6 equal to y. Now important thing is, from this I am trying to get x, because x is nothing but f inverse of y, and we are trying to find f inverse only. What I'll do, first I'll take 6 to the right hand side. This will become y minus 6. 2x plus 3 whole square equal to y minus 6. 2x plus 3 equal to root over y minus 6. From this 2x equal to what? Take 3 to this side, minus 3 plus root over y minus 6. Right? So, question number 6, 7, 8, 9 and 2 example problems. So, total 6 problems we did for 5 marks, related to 5 marks. Right? So, only by learning 6 questions, you will get 5 marks, means no one will miss this chance. I hope especially you. Right? So please practice these 6 questions to get 5 marks easily. I hope you understand this class. I'll see you in next class. Thanks for watching this video. Have a great day.